So you accidentally push a secret to your remote repository. Maybe it is GitHub, GitLab, Bitbucket, Gitya, Joe, whatever it may be. It could be an API key, an access token, it could be database password, it could be AWS secret key, it could be AWS access key, it could be webhook URL or JWT token, whatever random token, whether it is random, whatever it is. Now, what exactly do you do? What do you do in this case? Now, a lot of people immediately they remove the secret from the code, they commit the change and push again. But that's not actually the first thing you should do. Now, once that secret has reached a remote repository, you have to assume that it is compromised. You have to assume that. Now, so first thing, number one, you contain the blast radius. Now, what options do you have when you want to contain the blast radius? You can either revoke the credential or you can rotate it. Personally, if I don't need that credential immediately, I prefer revoking or deleting it. But why? Now, because it is fast. If it's an AWS access key, I deactivate it or I delete it. That's what I will do. Now, if it's an API token, you revoke it. Now, the fact that it is exposed, the fact that you take it out, the fact that you revoke it means that the exposed credential becomes useless. Remember, you either deactivate it or you delete it. You revoke it or you do whatever. It becomes useless. Now, the downside of that is if an application depends on it, that application could stop working immediately until you create a replacement. So for something that's not critical, my approach is, number one, I revoke it first, then I replace it later. Remember, I said it is not critical. But what if the credential were to be running important production service? That affects the users, that is live. Now, you probably don't want to immediately delete it and bring production down. This is where rotation makes sense. So what happens is you create a new credential and you update the system using the old one. So the system that is using the old one, you update it by replacing. It's just like replacement. Now, you confirm that everything works, and finally, if it all works, you revoke the compromised credential. Now, the advantage of this is that you maintain service availability. Any workload, any user-facing workload, or whatever it is internal to, they continue to be available. They are usable. They are, they're getting service. They get network. They're accessible. However, the disadvantage is that it takes more coordination. So, and the exposed credential remains valid until you revoke it. So I'll explain this. You have to go through so many loops, so many ends. You have to touch this endpoint, revoke and replace. You have to coordinate with different teams, development team, whatever team it is you're working with, whether it's the QA, even yourself as an engineer. But in this case, you will keep the infrastructure, you will keep it working, but again, you keep there is a likeliness that the exposed credential is still live until you revoke it. Now, so the decision here is simple. If downtime is acceptable, revoke it immediately. If downtime isn't acceptable, rotate quickly, then revoke. So what I mean is downtime acceptable. I can accept some downtime, revoke the secret. If, oh no, these are production workloads, then you can't afford any what is it called? Any downtime, then you have to do a rotation of whatever the secret is. So now, the next thing you do is you want to check your audit logs. Was any of the credential, was it recently used? If, let's say for instance, it's an AWS key, it's an access key, you want to go check CloudTrail, AWS CloudTrail, you want to see who has recently used it. When was the last time it was used? Pending or prior to the time or after it was exposed. Now, If it's a database credential, you want to check the authentication logs, who logged in, who authenticated. Remember, this is auth we're dealing with here. And you look for unusual logins. What are the API calls that were made? What resources changes happen? Is there anything suspicious? Did anyone suddenly increase the usage limit? Did anyone suddenly increase the threshold? These are the suspicious things you want to look at. Now, if everything is good or you have dealt with it, now you can come and deal with Git, because that was where it got lost in the first place. Now, here's another common mistake. Deleting the secret from your latest commit does not necessarily remove it from the repository. Git keeps history. Now, someone could simply go back through your previous commits and find that credential. So you may need to rewrite your Git history. One common recommended tool that you can use is called git-filter-repo. Now, you can install it with pip. You can install it just using pip install git-filter-repo, and that will save you a lot. And you will use it to remove the secret from your commit history and then carefully force push the rewritten history. Now, here is another caveat to it. If you're working with a team, remember that rewriting the history affects other people's clones and their branches, so you will have to coordinate with them properly. Now, another thing that you could do is you could have, this is a preventative measure, you could have a tool called GitLeaks. You could have it, maybe the developers, the engineering team, they have it at their machine level, at their hardware level, in such a way that before the code gets pushed upstream to Git, it stops, the pipeline does not even get to start. It stops, it never leaves your hardware. So that's one other thing we want to consider. Now, another important thing to remember, as I said, is that you cleaning Git does not make it make the credential to be safe again. That is why revocation or rotation comes first. Then you investigate, then you clean the repository, and finally you prevent it from ever happening again. I'll go through these steps. Again, I said cleaning the Git does not make the credential safe again. So the first thing is you want to revoke. That means to contain. I call it CICP. So what I mean by CICP is you contain, you investigate, you clean the repository, and finally you do the preventative measure, which I mentioned earlier, and there are so many other measures. So yeah, CICP. Clean, contain the blast radius, investigate, you clean the repository, and you prevent it from happening. Then another thing, if you don't want another way, as DevSecOps engineer, DevSecOps brain comes in now. You want to use Secrets Manager. You want to leverage the usage of Secrets Manager. You want to use Seal Secret, that is from Bitnami. You want to use Seal Secret. There are so many preventative measures that we could put in place here. And you also want to add all of your secrets to git-ignore so that it does not get tracked. Again, I already mentioned that you could use the pre-commit checks, and don't hard code credentials inside of don't hard code credentials inside of your application. My bad. So if you ever get this question in DevOps or cloud interview, remember these 4 words. You want to contain, you want to investigate, you want to clean, and you want to prevent. So because deleting a secret from Git removes the secret from your repository, but revoking the credential removes the attacker's ability to be able to use it. And those are 2 very different things. Thank you for joining. I hope you like this video and I hope it helps someone. If you do like it, please do not forget to give me a like. Don't forget to share this post and recommend it to others that may need it. Thank you, and have a good one.